Hello guys, and then welcome to another video. In this video we will be talking about finding effective resistances of a circuit. Okay, so this will be a continuation of the previous video. Okay, the previous video talked about short circuits, open circuits, resistors in series, and then what's in parallel. So this will be like a continuation of that video. Okay, so in case you are new here, kindly subscribe. Okay, subscribe and then hit on the bell icon. Okay, so that you don't miss out on any video. Okay, and then kindly like the video and then share, and then let me know your comments in the comment section. Okay, so we already know the formulas for finding the total resistances. Okay, whether they are in series or they are in parallel. Okay, we did that in the previous video, so in case you haven't watched the previous video, kindly do, so that you get abreast with whatever we will be talking about in this video. Okay, so let's first start with the formula for finding resistors in series. So we know that it's just the total resistance, so you add them up. Okay, and for resistors in parallel, so this is how we calculate the total resistance. Okay, now let's take the first example. Okay, so whenever you come across a resistor, okay, and then they are arranged in a circuit, first you have to identify whether the resistors are in series, okay, or they are in parallel, okay, before you find the total resistance. Okay, so in the previous video I taught you, or I introduced to you how to simply find the resistors which are in parallel. Okay, so if you've not watched that video, kindly check our playlist and then you find it over there. Okay, it could also be in the description, so in case it's not in the description, kindly go to our playlist and then you'll find the video over there. Okay, now whenever you see a circuit with resistors, first you have to identify whether the resistors are in series or in parallel. Okay, we talked about resistors which are in series having the same current passing through them. Okay, and then resistors which are in parallel, that's when we traversed through them. Now let's first take resistors which are in parallel. From this example we could just pinpoint resistors which are in parallel, because from just looking at it you could notice that resistor 2 and then resistor 3 are in what? Parallel. Okay, and then resistor 1 and then 2 are also not in parallel, right? But first you have to identify whether you could sum the parallel and then come up with another form of or group of resistors which are in what? Series. Okay, so let's first take a look at resistor 2 and what? 3. Okay, so let's traverse through them and see. Okay, let's start from here. So when you traverse through this, okay, great, we didn't meet any other element, so 2 and 3 are in what? Parallel. So we have 2 in parallel with what? 3. So when finding this, we have what? 2 what? Multiplied by 3. Okay, and then we have what? 2 plus what? 3. Okay, so this will give us what? 6 on what? 5. Okay, yes. Now after finding this, we are not done. Okay, we've now been able to find resistors which are in what? Parallel, but we have another resistor over here. So how do we combine this to that? Okay, in simple terms, this is what you have to do. Now we just simplify this resistor into this form. Okay, so we know this, we know that we have a voltage over here. Okay, now and then we keep this resistor. Okay, we keep this resistor, so we have this and then we have that. So all you have to do is just represent resistor 6 on 5. Okay, that's 0.5 ohms to what? This what? 1.5 ohms to what? Into this form. Okay, so instead of representing the 6 on 5 ohm resistor, okay, ohm resistor with 2 and 3, just represent it by just one resistor. Okay, something like this. Okay, right. Okay, so we have what? 6 on 5 ohm, okay, and then we have our 1 ohm, right? So after that we just find our total resistance. So from here I already told you that whenever you see two resistors and then they have the same current passing through them, they are series resistors, okay, or they are resistors in series. So all you have to do is just add them, okay. So our total resistance, okay, will be equal to 1 plus 6 on 5, okay, and this will give us 6 plus, okay, that's 11 on 5. All right, there's a simple trick we use to find fractions like this. I might teach you in the future, but you might not need it. SHS students might need it, okay, maybe JHS or SHS students, but I might introduce it in the future, okay. So that's 11 on 5 ohms. So we are done with question 1. You see how simple this is? Yes, this is how you solve for resistors which are either series or parallel, okay. Now let's look at the second example, okay. Now we have from here we could just first identify resistors which are in parallel and then which are in series, but let's always take note of those resistors which are in parallel first, okay, so that it becomes easier when solving resistors, total resistances, okay. Right, so you could notice that resistor 2 and then resistor 2 are in parallel, okay. I'll prove to you right away, right, but I wanted to just mention it though so that you get to know what I'm trying to say, okay. So let's try proving that. So let's start from here. Let's traverse, okay, let's traverse through them, okay. So we have this, right, yes, so we didn't meet any other element, so we have resistor 2 and 2 being parallel, so we have 2, right, multiplied by 2 all in 2 plus 2, okay. So we have 2 by 2 is 4, right, and then 2 plus 2 is 4. This is 1, okay. Now and then we just simplify this again, so we have the voltage source, okay, and then this 1 ohm resistor will be represented over here, right, now, okay, and then we just simplify the 2 ohm, okay, which are both in parallel, into 1 ohm, right, into 1 ohm. So this is the 1 ohm over here, right, okay, and then we will represent this 1 ohm to right here, okay, yes. So from here we could notice that this resistor and this resistor are in series, because the same current is passing through them, okay. The same current, maybe I, right, is passing through 1 ohm and this 1 ohm. So you have 1 plus 1, which is 2 ohms, okay. Now let's look at the third example. So right, so we have another resistor, okay, resistors, okay, in a circuit. So let's try find those which are in series and then parallel, okay. So now we could right away know that or identify that resistor 6 and then 4 are in parallel. Yes, your guess was right. So let's traverse or just prove to find out whether our initial assumption is true, okay. So let's traverse through them. So we have from here, right, through there, and then yes. So you can notice that we didn't come across any other element, okay. So we know that now resistor 6 is in parallel with 4, okay. So we have 6, okay, multiplied by 4, right, and then we have 6, okay, plus 4. We are not done yet, okay. We are not done yet, so let's continue, okay. Now let's break this resistors down, okay, just like how we did in the initial, okay, stages, just like here, right, just like here, okay. So let's just break this down. Let's keep the voltage, okay, let's keep the voltage, right? So there we go. Now let's keep this 3 ohm, okay? Let's keep the 3 ohm, right? And let's keep this 2 ohm, okay? Let's keep the 3 ohm, 2 ohm, right? And now let's keep this over here. So you can just check that we have what's our resistors which are in parallel, okay? We have that to be 6, okay? 6 times 4, and then 6 plus 4, that's what 24, okay? On what? This is 10, okay? Right, so 24 on 10 ohm, right? Now so we can bring that 24 on 10 ohm over here, right? Just represent it over here, okay? So this is our 3 ohm, this is our 2 ohm, and this is our 24 on 10 ohm, right? Yes. So now let's continue, okay? So from here we could again notice that resistor 2 and 24 are in what? Series, okay? Yes, because the same current will pass through this and that, right? So we have what? 2 plus 24, okay, on 10, okay? 2 plus 24 on 10, right? Now 2 plus 24 on 10 will give us let's see, this 25, okay? So we have 22, this 22 on 5, okay? You have 22 on 5 ohms, right? Okay, you can just point this on the calculator or just use the approach I'm using. I'm using a simplified approach. I'm using a certain trick. That's why my answers come a bit late, okay? I'm not trying to use the calculator, okay? But you can just use the calculator and then you arrive at the same answer, right? Okay, so and then after this you can just simplify this further, okay? So that you get our voltage source again, right? And then we have our 3 ohm, okay? Our 3 ohm. And then you represent this one, okay? Over here, right? You have that, okay? So you have what? 22 on what? 5, okay? Ohm, and then we have what? 3 ohm, okay? We have what? 3 ohm, right? So from here you could notice that most definitely this is in what? Parallel, okay? Because once we traverse through this, there is no other element, okay? So we have what? 3, okay? Multiply by 22 on 5, okay? Divided by 3 plus 22 on what? 5, okay? And this will give us okay, so we have what? 66, okay, on 37, okay? 66 on 37 ohms, right? So from here you will just realize that we've made this approach as simple as possible so that you get to understand, okay? Now let's move on to the last and final example, okay? So now I'll do this straightforward, okay, so that we won't waste too much time on this. No. So now let's see. I'm going to simplify this as simple as or as best as I can, okay? So now let's see. You can notice that this is in parallel, okay? 1 ohm and 1 ohm is in parallel. So you have 1 ohm will be in parallel with 1 ohm, okay? Plus, now we have what? The answer we will get here will be represented in this format, okay? So we have what? This, okay, with our voltage source, alright? And then we have that, another resistor, and then we have this one, okay? This one, okay? We have that over here, and then we'll represent this over here, right? Yes. So now we could also notice that this, okay, this resistor and this resistor are in what? Series, because the same current will pass through them, okay? So plus 1, okay? Yes. So let's keep on breaking them down. Now we have what? This resistor, okay, this is already 1, this is also 1, right? This is also 1, okay? Now, okay, this was 1 initially, but we've added that to this 1, okay, because it's already in what? Series with what we had over here, okay? Now let's move on. With this we have what? That, okay, this. Now we found this, so remaining this one, okay, so we have what? This, okay, right, and then what we will get over here will be represented with this, okay? So you have 1, 1, and then the whole of this over here, okay? The whole of this over here. So from here to we could identify that, or we could notice that this is also in parallel with this one, okay? Because no element is found after traversing, okay? So that will give us what? So let's put this in brackets, in another bracket, okay? So that will give us what? Plus that one, okay? So you have this one, right? Because this is 1, okay? This is the one we represented over here, because it will be in what? Parallel with the whole of this, okay? Now let's break this one down again. So you have what? We have this, okay, in this format, and then we have what? That, and then you just break this one down, okay? Okay, there we go, right? So from here to, we will notice that this resistor will be in parallel with this one, okay? So this one will be in parallel with the whole of this, okay? Yes, so we have this, right? Okay, so that will also be what? In parallel, okay, with this, okay, right? Now once you solve the entire of this, you end up with your final answer being what? 3 on what? 8, okay? 3 ohm, okay? You can just simplify this further and then you arrive at the same answer. Thank you for following me throughout this journey, and then I'll see you in the next video, okay? Kindly subscribe, like, and then comment in the section below, in the comment section below, okay? Our next topic will be current division rule and then voltage division rule. See you in the next video. Bye bye.